All right, number 18 asks us to use the factor theorem to determine if the binomials given are factors of f of x, and then use the binomials that are factors to write a factored form of f of x. All right, so this is f of x. F of x equals x to the fourth minus x cubed minus 7x squared plus x plus 6. And then the binomials that they give us to check to see if these are factors are x plus 2 and x plus 4. So they want us to divide the f of x by these two potential factors, and we'll know if they're factors if after dividing them we get a remainder of 0. All right, so let's start by putting the coefficients here. That's 1, negative 7, 1, and 6. And then remember that we're always, when we're doing synthetic division, we're always dividing by x minus the number we put out here. So we want to divide by x plus 2, so we're going to put a negative 2 out here, because x minus negative 2 is x plus 2. All right, so we drop down the 1. 1 times negative 2 is negative 2. Add those, you get negative 3. Negative 3 times negative 2 is 6. Negative 7 plus 6 is negative 1. Times negative 2 is positive 2. 1 plus 2 is 3. 3 times negative 2 is negative 6. So we did get a remainder of 0. So x plus 2 is a factor. And now that we've divided this out, we're left with x cubed minus 3x squared minus 1x plus 3. And so if x plus 4 is a factor of f of x, it should also be a factor of this, because all this is f of x with x plus 2 divided out. So let's test x plus 4 here. So we'll put a negative 4 out here. Drop down the 1. 1 times negative 4 is negative 4. Add those, you get negative 7. Negative 7 times negative 4 is 28. Plus negative 1 is 27. 27 times negative 4 is negative 108. Plus 3 is negative 105. So obviously we didn't get a remainder of 0 here. So negative 4 is not a factor. I'm going to go ahead and erase this. Please leave that on your test to show your work, but I wanted to make it clear what I'm doing next. So x plus 4, or x plus 2 is a factor, x plus 4 is not a factor. So we've divided out x plus 2, and what we're left with now, we've got f of x is equal to x plus 2, that's what we divided out, and multiplied by this, which is x cubed minus 3x squared minus 1x plus 3. All right, so now let's, this we should be able to factor, and we can get this down to a completely factored form. So let's group these. So we get f of x equals x plus 2 times, and we'll make a couple groups out of this, x cubed minus 3x squared plus negative x plus 3. So this we've already done, we're just factoring this right now. So x, let's take an x squared out of that. And we're left with x minus 3. And then over here, let's take a negative 1 out of that. So we're going to be negative x minus 3. And now we've got an x minus 3 in both of those terms. So we can factor that out. We get x minus 3 times x squared minus 1. And so we've just been working on this part. Of course, we also have x plus 2, that's equal to f of x. All right, this is almost done. There's one more thing that we can do here. Here we've got x squared minus 1. That is a difference of squares, so we can factor that out further. So our final answer is going to be f of x equals x plus 2 times x minus 3 times, and x squared plus 1 factors to x, or sorry, x squared minus 1 factors to x plus 1 times x minus 1. And that is going to be our answer in fully factored form. So the answer is yes, x plus 2 is a factor. No, x plus 4 is not a factor. And the fully factored form is f of x equals x plus 2 times x minus 3 times x plus 1 times x minus 1.